Hi everyone, it's my pleasure to be here, and obviously my voice is a little bit weird. That's because I have a cold lately. So with that, these flowers for you guys. That moment, I realized that's we already have the point, or wondering the trick. I love this one when I saw it on Instagram. So all that coming up. Hi again, this is Dyson. Welcome to my home. My goal is to clarify things, simplify things in a clever way. I believe in that way we'll enjoy the life. So to create something you need the inspiration. So I got inspired by this. You see that? I love this one when I saw it on Instagram. So especially for this one we're gonna use combination of software to achieve that fast as possible. So before we begin, if you enjoy this kind of video, please hit the like button and subscribe for more content and help us the channel to grow. So let's begin. Okay, let's begin with the basic container flip in the sub level. We're gonna use flip for this one. Okay, this will be our container. Now the flip boundary, basically that's the flip source and flip solver. Okay, let's connect a sphere as a source here. Okay, that's the basic fluid. Let's have a ground plane here. Okay, not bad. Let's bring this one a little bit up. Okay, it's outside of the domain. Let's adjust the container to include it. Okay, now let's play. Okay, it's good start, but let me use this expression here to have a source just in the one frame. Cool. Now let's adjust maybe the size. This size, it's so important in the simulation, especially in Houdini. And for example, this container, aka tank, and let's have maybe some viscosity. Okay, yeah, this is cool. Now let's have a flip collider. Let's create one. Sorry, flip collide. Okay, now let's have a decent geometry, maybe tube or this cylinder. Okay, that would be our collider. So let's play and see what we have now. Okay, I will try to make it interesting, but it's okay for this demonstration. Okay, let's proceed. Okay, now we have our particle. Now let's mesh this one with the particle fluid surface. This is the fastest way to mesh a particle. That's okay with the default setting. Now let's have a line, for instance. Let's pretend that's our flower, and let's copy to node this one. Sorry, copy to point this one. Okay, as you can see, the direction is respect the normal vector. That's why we have this craziness lines here. And let's adjust this vector, normal vector. You see, we don't have any normal vector. We need to create one. Let's use normal node here. Okay, let's override that and change that to point. You see, we have a normal vector, and let's set that to 0 and see the magic. That's so cool. You see, the flowers or the line is facing upward by default. See that? So now we have this issue these points are copied to each point, you see the above and below. So I need just the above surface, as you can see, and I want the fastest way to achieve that. Okay, in that moment I thought maybe let's lay down a delete node here to select randomly a point and delete them to decrease this amount of flower or these lines. Okay, maybe this one, you see that, but the issues remain. These points are copied below. Okay, what we can do with it, you see that?
Okay, that's tricky. I need the fastest way. So in that moment, I realized we already have the point. And for those guys are wondering the trick, so this is your answer. Let me show you.
The answer was simple. You see that we have already the particle point. That's the flat surface I need. Okay, I will delete the fluid surface mesh and voila, we have this particle with the line. Let me show you, and that's what I needed. Okay, that's obviously the fastest way to do this, and I'm pretty happy with it. With that, let's proceed. Now let's replace our lines with this geometry. By the way, this is available on my Patreon, the source file and this geometry. We're gonna use this red rose here. Okay, before you copy this one, make sure you enable this pack instance, otherwise you will end up exploding your system. Believe me. Okay, you see we have this flower. Let's disable this color with this flip solver, and let's adjust our size, and yeah, it's not bad for the start. And this is the flower. Okay, let me show you in the simulation. Okay, not bad at all. Okay, we're gonna adjust that later on. Now, as you can see, we have another plant here. See, I love it. Okay, make sure these sizes are matched together and in the same origin position in the workspace, and let's merge these guys together and let's see what we're gonna have here. Okay, let me show you. That's bad. As you can see, it's laid down on each other. Okay, in order to have a randomization of distribution in the point copy to point node, we need to transfer the name pieces to the point. Let me show you what I mean for that. Let's create attribute transform pieces or from pieces, and we need the name attribute. Okay, let's create one. Name, of course, it's primitive and string. Cool, and let's call that a rose, for example. Let's copy paste that here. It calls that, for instance, planet. Cool. Now let's connect these guys here. Okay, it's wrong order. Let's shift that. Now we have it. Okay, we have the name attribute, as you can see, and now let's connect this one instead, and you see nothing happened because we need to do one little thing. Let's enable this pieces attribute, and voila, we have the distribution. Okay, let's randomize thing here to make look better. First, the direction of these flowers. Let's create randomize attribute node here. Okay, and let's select our n for normal, and of course we have something, but we need the direction one and orientation, and it's not that's good. Here we can adjust it in this slider. Cool. And yeah, it's not bad at all. Adjust it as you need it. Now let's see it in the flipbook. See the simulation. Okay, not bad. We're gonna use that. Okay, now we have this size of this flower. If you want to make it random, you can use attribute float adjust. Okay, to adjust the p scale, by default is selected, and let's have a random value and adjust that based on you need. Okay, as you can see, we have intersection issue with the flowers here. That's because the foundation of fluid particle is to intersect with each other. Okay, to fix that, for instance, I will use this trick in this video. Okay, let's create a VDB from particle. Let's bring this down, and we have our VDB. Now VDB to sphere. Okay, and we have our sphere here, as you can see. Cool. And you see that. Let's decrease the amount and let's uncheck overlapping. That's cool trick, and that will work, but with some issue here. Let me show you. And of course we can adjust this size here, because the VDB to sphere, it's adjust the p scale attribute, and you can see we don't have any intersection now. And let's show you in the flipbook what's going on here with this solution in this situation. You see, every frame is changing the position and the particle, so that will not work. Instead, you can use this volume constraint grain or grain solver, and let's connect this one to the sphere, and of course this one to the collider, and let's enable this ground plane to match it with the flip solver. Cool. And now we have this one. Let's enable that, and we have our grain. And let me show you what we're gonna have with the grain here. And this is this difference between grain and flip solver. You see, the grain particle is push each other, but the flip, on the other hand, it's intersect with each other. You see that? And that's so awesome. Okay, instead of flip solver, you can use this volume solver here, and of course we can mimic this movement with this setting, for instance velocity dump, and we have this one. And let me show you in the flipbook. That's awesome. You see that?
And of course, for those guys are interesting, all these assets are available on my Patreon, which the link in the description. Okay, now lately I am thinking like a mechanic. You see, mechanic use any possible tools to achieve his goal or fix the problem. In this one, I will use Cinema 4D for the sake of simplicity and fast approach. Let me show you.
So this is the final scene, the Patreon version. We have this tutorial one and floating flower. This is the final version. Let's go to this one. Okay, you can see this setup I made for you guys here. I have this switch. You can use the flip solver. I use the flip solver because I love the movement, honestly, rather than volume solver. And I use this time scale to decrease the movement. And of course, if you want to render that in Houdini, of course go ahead, but for me, my render pipeline is in Cinema 4D. That's why I'm exported. and I clean up this geometry by attribute delete, and I export that as a limbic. So you may ask why I use this point instead of whole geometry, the flower geometry. You see, if I export this whole amount of flowers to Cinema, it will be so hard to transfer this via ABC or a limbic file. So that's why I use this point instead of the whole geometry. So in Cinema 4D, I have these two objects and of course decent sky, physical sky, and this backdrop. You can see I create that with this spline here. It's decent object, of course, and let's hit APR renderer. You see that I have this flower, red rose, and this one here. Cool. Now let's open our Alembic file here. As you can see, I change the scale to meter and I import the point as a polygon object, not particle. So that's our simulation. I love it. Now let's create cloner object to clone some object to this point. This is our cloner. Okay, let's select that, and for instance let's have a cube. I want to demonstrate something for you guys. Let's bring this cube down a little bit, and we using the grid now. We can use the object. Let's drag our simulation and let's change that to vertex, and voila, you can see it's choppy. Let's enable multi-instance. That's basically the packed instance on the copy to point in Houdini. So this is now more fluid, and let's have this flower. As you can see, it's cool. We copy this flower here. As you can see, the intersection issue, it's remain. Okay, I want to fix that. Let me show you with this effector called push apart effector. Of course, I talk about this on this video here, and let's change this setting here, the radius. You see, it's pushing this instance or this object. Okay, I will use this 3 centimeter, and that's cool. You see, it's the fastest way to solve this intersection issue in Cinema 4D without going to Vex or any programming or VOP operation. Now let's have a random effector. Of course, we can use this rotation parameter to randomize the orientation of these flowers. You see, that's not bad at all. Okay, I love this one. I'm not going to push it harder. Okay, now let's have another plant here. You see, the orientation is not cool. Let's disable these coordinates. Okay, that's so cool, and let's change that to random distribution, and voila, we have this simulation. And let's turn that to bounding box, for example. Okay, sorry, bounding box. Okay, that's just for the display and sake of speed workflow. And with Arnold renderer, it's cool. It's see this multi-instance thanks to Autodesk Arnold renderer. I love this renderer. It's my favorite, honestly. And as you can see, we have this flower. We gonna randomize these colors by going to this material, of course, and we have awesome node here by Arnold renderer. It's called jitter color, I guess. Let me show you. Color jitter, sorry. And let's connect this one here, the source file, and the second one on the material. Let's go to color jitter, and we have this object section, face, and procedural user data. and we're gonna use this object, and let's change the hue, and voila. That's so amazing, and honestly I love this workflow. It's so fast and cool. You see, we have this hue and the saturation. Of course, we can bring it down for white roses. You see, I love it. And of course the gain. Okay, you can randomize thing, and as you can see, that's what I did with the final result. And with that, this is the result, and I'm pretty happy with it. And honestly, I'm so happy I did it. And with that, guys, that was a pleasure. See you in the next one. Goodbye.